Okay, now we'll see how to reduce the size of an LV. Okay, so reducing the size of LV is not like increasing the size of LV. Increasing the size of LV is somewhat easier task, because we can increase the size of LV online. That means without downing that system, without making the system down, without unmounting the file system, we can do that. Okay, because increasing means already it is having some space, so we can add some more extra space to it. But whereas reducing the size of LV is somewhat complicated task. Why? Because we want to reduce the task of that LV. We don't know where on which blocks are reduced. Okay, so it is a down, it requires some downtime. You cannot reduce it online. That means downtime is nothing but unmounting that file system, because every LV is attached to some directory. That is nothing but mounting. So okay, so say a mounted LV, it cannot be reduced online. Okay, so you must unmount it. You know how to unmount it, simply using unmount command. Next, after unmounting that mount point, we need to resize that LV. Before doing that, you must check the file system consistency of that LV. So by using this command e2fsck-f, and this is LV path of that LV /dev /vzname and /lvname. Okay, first you need to unmount that file system which is mounted to that LV, the LV where LV is mounted. After that, you need to check the file system consistency to organize the data in LV by using this file system consistency. Okay, you must run it. So otherwise, there is a chance of corrupting the file system. Okay, you must do that. After checking that file system consistency, you must resize that file system also. So because previously that LV is having some space, now we are reducing that LV, so the entire file system is occupied, the entire LV is formatted by some file system. Now you need to resize the file system also. So for that, the command is already, you know, this resize to fs and LV path name, and how much amount after reducing the LV size, how much the size is, you must mention it. Suppose if you are having 500 MB LV before reducing the size. Now if you reduce that by 200 MB, okay, you must mention that value after reducing that. So 500 minus 200 is nothing but 300 MB. Okay, so now that entire file system applies to this 300 MB only. Previously it is 500 MB. So now I want to reduce, not yet reduced, I want to reduce that by 200 MB. So 500 minus 200 MB is nothing but 300 MB. So you need to run this command resize to fs. That means resize the file system to this space only on that LV. So now my LV is only having 300 MB. I need to apply my file system to this 300 MB only. Previously it is 500. Now it was reduced to 300 MB. After resizing only, you need to reduce. So to reduce that one, you must run this command lv reduce -l minus 200 m. You must mention minus. Okay, minus this much amount I am reducing. 200 MB I am reducing from 500 MB. Okay, and the path of that LV or LV name. Okay, after reducing LV, you must mount that LV and check that by using a df-h whether that is mounted or not. Okay, whether to check that whether that change is whether it is reduced or not. Okay, so once again I'm repeating this one. To reduce an LV, so reducing the size of LV is an offline activity. It is not an online activity. It requires some downtime. So in real time, it was done by creating a change management. By change management, they will do this thing in real time. Change management is nothing but it is an planning activity. So in real time business, without interrupting business, they will plan a particular time. Okay, on that particular time, the business, they don't have the business on the production server. They will make sure that like that, and then only they will start doing this. So that is called change management. Okay, so for that they require approval from all the authorities like that. Okay, so it is a complicated task in real time. Okay, you must plan it accordingly. Okay, so reducing an LV is an offline activity, increasing LV is an online activity, of course, no problem with that. Okay, and to reduce that LV, first step you must do is you must unmount that file system on which LV is mounted. Okay, so first you must run unmount command. After that you must check the file system consistency. You must organize the data in LV by using this e2fsck command. Here -f means forcefully. Okay, and this is the syntax. Next, after checking the file system consistency, you must resize that file system, because we want to reduce that LV now. So you must apply that file system to only the reduced size only. So you must calculate before doing that. Okay, you must apply this resize to fs command on the size of the LV which was remained after reducing that one. Okay, after doing this you can run this command lv reduce -l and how much amount you want to reduce on the existing LV. Okay, suppose it is minus 200, so you must mention like this minus 200 m. Okay, after that again mount that LV. So check whether it is changed, the size of the LV changed or not, by using df-fh command. So we'll check on the practice session. Okay, okay, now check how many LVs are there. By using lvs command we will came to know. So I'm having only one LV1, one LV, that is LV1 on VZ1. Okay, its size is 1.5 GB. Okay, now I want to reduce the size of this LV to 1 GB. That means I need to reduce the size by 500. I need to subtract this by 500 MB. So if you subtract 500 MB from this 1.5, so you will get 1 GB. Okay, now we will do that one. So first you must what you need to do is you must unmount the file system on this LV1. So how to know which file system is mounted on this LV1? Okay, so for that one you can run this command df-h. Okay, this will give the mount points on the present existing system. A df-h command will give the output of mount points on the system. So look here, this is my present LV1. Its size is 1.5 GB. Used is 1 m 11 m 11 MB, and 1.4 GB is free. Okay, now it is mounted on this one. Okay, /lvm dir. So first step is you must unmount this LVM /lvm dvr. Okay, so for that the command is to unmount any mount point. The command is umount. Check whether it is unmounted or not. Okay, look here, so it was unmounted. So df-h will give the output of currently mounted mount points on the system. So previously it was mounted, this one LV1, before doing this unmount command, running on unmount command. Now it was unmounted, so it's not showing in this one. So df-h output comes from / it is a m tab. Okay, so m tab consists of currently and permanently mounted mount points. Okay, just now I have unmounted it, so it doesn't produce that mount point /. Okay, next command is you must check the you must organize the data by running this e2fsck run command. E2fsck -f, and my LV name is /dev vz1. Look here, this is my LV name. Okay, LV vz1 LV1. Okay, look here, one more important thing is when you run fsck, of course we can run fsck command or e2fsck command on a file system or on a LV. So it will produce the output in 5 stages. So first one is it checks inodes, blocks and sizes, whether it was corrupted or not, or it will organize the data. So at the time of file system introduction, I told you what file system will do. It will organize the data in an organized manner. It will arrange the data in an organized manner. So how it will arrange means it will arrange it in the form of blocks, sizes, inodes, okay, everything. So first phase is when you run a e2fsck or fsck command. Fsck means file system consistency check, okay. So first one is it will check inodes, blocks and sizes if there is any correction is there, and after that it will check the directory structure. After that it will check the directory connectivity. After that it will check the reference counts. After that it will check the group summary information. So whenever if they ask in interview, you need to tell this, what is the output of fsck command, fsck or e2fsck command. You need to tell all these 5 inodes, blocks, sizes, directory structure, directory connectivity, reference counts, group summary information. You need to remember this one, okay. So why we need to run this e2fsc command is you must check the file system consistency. After unmounting that mount point, if you run this command, it will check whether the data is corrupted or not, okay. If that data is corrupted, then it will produce errors. e2fsc command produce errors. So now it is okay. So the data is no problem with the data, okay. So that's for that reason we'll check file system consistency after unmounting any mount point, okay. If there is some disk error, it will produce errors, okay. We'll check that by using the e2fsc command or fsck command, okay. After this, after running the e2fsc command, what you need to do is you need to resize the file system of that LV. So now how much amount of data I want to reduce, okay. So how much amount of data, how much amount of space I want to reduce from the existing LV is at present my existing LV size is 1.5. I want to reduce it to 1 GB. That means I want to reduce by 500 MB, okay. 500 MB data, 500 MB space is detected from this LV. So while running this resize to fs command, you must be careful about this, okay. My command is look here, once again I'm showing you resize to fs command, LV name, and the size of this one is the size of the LV after reduction. You must mention that one, okay. You must give the size of the LV after reduction. So present my size is 1.5 GB. I want to reduce the size by 0.5 Z. So after reduction it will be 1 GB. So resize to fs, I need to run the command like this, resize to fs, my path of that LV. So /dev vz1/lv1, this is the path of LV, and the size is 1 GB, okay. So you can mention like this, 1 GB, okay. So the size was reduced to 1 GB, okay. After reduction, how much size you must calculate this before doing that, okay. Next step is, now it is the final step. What was that one? You must reduce the LV. So further the command is LV reduce hyphen capital L. Whenever you give capital L in LV concept, that means that indicates the size in MB or GB. So now I want to reduce the size by 500 GB, okay. Sorry, 500 MB. So there you can do that by 0.5 G also, okay. And so look here, you must mention this minus. So if you don't mention this minus, it will take the entire size of that LV by 500, okay. Previously while increasing the LV already you have seen that one, you have given there plus increasing, here we are reducing, so it is minus. So you must give like this, LV reduce my hyphen L minus the size of how much size you want to reduce, the size and LV name. Okay, you must be careful doing this while running fs and LV reduce command. Okay, so next path of that LV name, LV1. Okay, reducing this size, this may destroy your data file system. Okay, it is asking because I'm reducing the data now. There is chance of destroying the data. That's why I have unmounted it. Okay, no problem with that, because I have unmounted that mount point on that LV, so no chance of losing data. So you can give that permission. So now it was reduced. Check whether it was reduced or not. Before checking whether it was reduced or not, you must mount that mount point. So you can do that by two ways. You can run like this: mount slash lvm dir. This is one way, and second one way, if you forget that mount point name, you can do this one also, mount hyphen a. This will do is, mount hyphen a means it will mount all the file system that are stored on the slash etc fstub. But in real time, don't run this command, because there may be some other users are there, they unmounted some file systems now, and also that mount point was given in slash etc fstab. But for temporarily, they, for some purpose, they may be unmounted that one. If you run this command mount hyphen a, there may be that all the mount points will be mounted, that are given in fs tab. So that is a risky one. Okay, so in real time, don't run this unless otherwise, if you know entire environment about that one. Okay, so you can use this mount hyphen a command, or you can use mount slash lvm dir command also. Okay, now check whether that mount point is mounted or not. Look here, slash lvm 930. Of course, it is giving approximate values, because 1000 something will be used now. So lvm directory, and the size is also reduced. Previously it was 1.5 GB, now it was approximately 1 GB. Okay, and also you can verify this that using lvs command. Okay, or lv display command, lv display and lv name. You must write that lv name. By using either of these things, you can do, you can verify that. Okay, look here, lv size is 1 point. It is in gib now, here it is in gb. That's why the difference. Okay, gb is different from gib. Previous class I told you. Okay, that's about how to reduce lv. Okay, next one is, that's about reducing an lv. Next one is how to move or migrate LV from one PV to another PV. So in real time, what will happen is, there may be some corruption of data on the present existing hard drive, or the hard drive may be damaged. Hard drive may be damaged means, that means PV was corrupted. Failing of PV may occur. Okay, in that situation, you must move your LV from one PV to another. That is also a real time task. Okay, so for that, you need to migrate that PV from to the other one, and you need to isolate that PV, or you need to remove that PV. Okay, for that, what you need to do is, first check that PV, failing PV is accessible or not. Access that mount point that are on the PV. Check the data in it. Data, whether check it whether the data is there or not. If the data is there, nothing we can do. If the data is there in it, then we can move it from one PV to another PV. Next, verify the size of that PV by PVS command. Why we need to verify the size means, you are moving this LV from this PV to another PV. Okay, for that reason, if you need to create new one, okay, new PV. Okay, so you must know the size. So for the size of the new PV must match with this one, same or more than this one. Okay, if your PV is 1 GB, you want to move this the LV on this PV to another PV, the newly created PV must have 1 GB or more than 1 GB, then only it suits it is good, otherwise data will be lost, you may lose the data on the LV. Okay, so again here, to do that one, again it is an offline activity, you must unmount the file system on the PV. Okay, next add the new PV, you know how to add the new PV, how to create new PV, and add that to volume group, that new PV. Okay, and after that move that old PV to new PV and mount back that LV and access point and verify again the data whether it is that data is in the not okay. Next remove that faulty PV. Okay, these are the steps you need to follow uh, while moving or migrating. So to remove that PV, you need to use this command vg reduce vg name, which PV you want to do that. Okay, I will show you practice session, you will understand clearly. Okay, now check check how many PVs there. My present LV is LV1. Next check PVs. Okay, I am having two PVs here. Okay, PV1 and PV2. One PV size is 1 GB, second PV size is 2 GB. Okay, now let us consider this PV was corrupted. Okay, failed. Now on that VZ1 we're having LV1. My LV name is LV1. Sorry. So my LV1 is on this VZ1. Okay. So this LV is mounted on these two PVs. VZ, of course. This VZ is comprised of these two PVs as SDB1 and SDB2. Now let us consider this PV was corrupted, or this PV was failed. Now I want to move this LV on this PV to another PV. Okay, for that I need to create a new PV. So before creating PV, a new PV, I need to check the size of this old PV. This SDB1 is having this much size, 1 GB. So I need to create a new PV with this size or more than this size. So you know how to create a new PV. First you need to format create a new partition by using fdisk command /dev, on which hard drive it is, STB. So it is that. Okay, check the information, print it. Okay, print. Okay, you're having two partitions on the disk. I'm going with another partition and new partition. Already two partitions are there. I'm doing that with third. Sorry, I'm taking it as standard primary partition, or you can go with the extend partition also. This is LVM, of course we can change later, we can change the Xcode, so no need to worry about that one. And third partition, okay, where I want to start 395, so simply enter it. So by default it will take 395, or you can enter 395. Okay, and how much size I want to do, I want to take the for this new partition, because the old existing PV is of 1 GB, so I I need to take 1 GB or more than 1 GB, so I am taking 1 GB. Okay, check whether it was created or not. So new third partition was created, the size is 1 GB, but it is a standard partition. So what you need to do is, you must change the Xcode of that standard partition. 83 is a standard partition, you must change it to Linux LVM 80, you must give it. So for that the command is T. So which partition you need to change? Third partition. So the Xcode for LVM is 8E. Okay, now I can check it whether it was reflected or not. Check it. Okay, it was done. For the third partition, the Xcode was changed to 80, that is it is of Linux LVM type. Okay, now you can quit after writing it to partition table. Okay, W means it will save. After that you need to update that to kernel by using portex-a, and which hard drive it is, STB. Okay, it was done. Okay, now the new partition with LVM Linux code was Linux exe code was created. Now you need to make it PV. So by using PV create, and which partition you are making it as PV /dev stb3. Okay, so third partition. Okay, okay, it was created. PV was created. Check whether it was created or not. PVS. Okay, look here. Third was created. Previous two are there. Those are under VZ1, but it was not allocated. PV. This PV was not allocated till now. For that, you know how to allocate this to VZ. Okay, how to do this one? You can do that in two ways. If you want to allocate for new VZ, you need to use VZ create, but you are extending this VZ, existing VZ. You are allocating to old VZ. That means we are doing that by VZ extend. Okay, VZ extend VZ. The name of VZ is VZ1, and newly added PV was /dev stb3. Okay, it is easily extended. Before that, the VG size is 1 plus 2, 3 GB. Now new one is added, stb3 as well, that is VZ1. Check the VG size also, VGS. So now it is 4 GB. Previously it is 3, now it is 4 GB. Okay. Previously the LV was mounted on these two only. Clear now? Okay. LV was mounted on these two. Now it was allocated to VZ, so totally LV was mounted on this VZ1. Now I need to remove this one. Before doing that, my LV is mounted on LV. My LV was mounted on, look here, LVMDAR. So if you want to remove this STB1 from this volume group, you must unmount it because there is some data in it. Okay, if you do that online, that is without unmounting LVDAR, the data you lost. Okay, so you must unmount this mount point. After that, you need to move this PV to this PV. After that only you need to reduce this one. Okay, so for that, first unmount slash that mount point which is on the LVM resides on which. Okay, so unmounted, check it. Okay, now it was unmounted. Now you can do whatever you want. Next, what you need to do is you have created a new PV. Next you need to move that old PV to new PV. So in our example what we are taking, this one STB1, we are considering this as old one, that means it was failed. Now I want to move this B1 to B3. So for that, what was the command is pv move. The old name of that PV is stb1, and new PV /dev stb3. Yes, it was moving. Okay, it will take some time because it is moving the disk from okay, 1.6 is over 70% because it needs to move the data from stb1 to b3 now. Okay, 100% is over. After doing that, I have moved that old PV to new PV. Next we need to again mount back that LV, access the mount point LVMDAR, check whether the data is in it. Okay, after that remove the faulty PV from that old group. How to remove that one is, sorry, how to remove that one is VZ reduce. Okay, you need to reduce the size of VZ from that PV. Okay, I will show you. Okay, it's done. Now mount back that LV. So I am mounting all the, so that it will mount all the mount points in FST tab. Okay, check it. Okay, LVM there. Now check whether it is accessible or not. Sometimes there may be failure of the disk hard drive problems are there, then we cannot access that one. Okay, so newly mounted one now, so check it. So I'm having file w. Okay, in LVMDR I'm able to access my LVDM. So it was successfully moved. Now check, it is my VZ1. I'm having 4 GB. Okay, so all the at now present I'm having 3 PVs. Okay, B1, B2, B3 all are under VZ1, but this was, I want to remove this one from this VZ. Okay, for that successfully I have moved this PV to this PV. Okay, now what you need to do is you need to reduce. Removing PV from VZ group is nothing but simply reduce the size of VZ. VZ size, my VZ name is VZ1, and my PV name which I want to remove from that VZ is B1, STB1. Okay, it was removed. Check it. PVS. Okay, look here, it was not allocated to anybody. Let how to remove permanently, how to remove this PV is I will show you. So just now I have removed this PV from VZ1 only, not entirely. I have not removed that PV. Okay, so I think you understood that one. Next, how to remove that PV. Okay, simple. PV remove PV name, that PV name. Okay, if it is a single PV, just use this command. If it is multiple number of PVs are there, 6,7, then you need to add it in curly brackets. So just if you run this command PVS, then it is showing we are showing this PV, but it is not added in that one. So now I want to remove this one, PV remove. Which one I want to delete? /dev stb1, this PV successfully wiped. Okay, now check it. Look here, stb1 also removed. Only we're having stb2 and stb3. Okay, like that you can remove a PV from a VZ, or we can move one PV or an LV and one PV to another PV. Okay, that's it. Now the next topic is